In this video, I want to talk about how to solve nonlinear equations in Matlab. So we've done root finding in other videos where you're solving equations of a single variable in one dimension, okay? Single nonlinear equation. And now we want to do systems of nonlinear equations, so it's a little bit different. So there's this f0 command that will solve single nonlinear algebraic equations. Now we're going to use fsolve, which will solve a system of nonlinear equations. As with f0, because this equation is nonlinear, there may be no solutions. There may be multiple solutions. You really should have a pretty good idea that there is a solution to your equations and what it is before you start solving it. All right. We do have to provide a guess for the solution because it's iterative. So again, it reinforces this need to have some idea what the solution is before you go and use these tools. So here's our model problem. It's a system of two nonlinear algebraic equations in two unknowns. So one equation is x squared plus 2y squared minus 5x plus 7y is 40, and then the other one is shown here. Okay. The first thing we have to do is convert these to functions. So Matlab wants to zero out functions as opposed to solve equations. So we just move the 40 and the 28 from the right side to the left side. And then we have two functions. So x squared plus 2y squared minus 5x plus 7y minus 40. That's the first function of x and y, and then the second one is below. And when we find values of x and y that make both those functions 0, then we have a solution. So again, fsolve is iterative. We supply a guess. We supply some Matlab script or function that will take a value of x and y and return the evaluated functions. And once we have that, then Matlab can do its iteration and find the zeros if they exist. So here's our main routine. We need to have this function that returns, or a script that returns the functions for a given value of x and y. So first thing you'll notice here is that the only argument to the function is z. But z is a vector, and z contains a guess or a value of x and a value of y. And so we have to evaluate our two functions in terms of those x and y values. Now I could just use z of 1 and z of 2 to evaluate the functions, but it's a little clearer for me if I let x be z of 1 and y be z of 2. And since I wrote my equations in terms of x and y, then I can write the functions in terms of x and y, and I'm less likely to make a mistake. So I let x be z of 1, y be z of 2, and then go from there. I could switch those if I wanted. I could let x be z of 2. It's arbitrary, as long as your guesses are consistent with the way you evaluate them, and then you interpret the output appropriately. So I'll let x be the first value of z and y be the second. So I set those up, and then I just evaluate the functions in terms of x and y. That's straightforward. So the only things you got to track are these names. EQNS is the name of the function, and FCNS is the name of the output. So let's just reinforce that. So EQNS is the name of the function, and when I save this script, I call it EQNS.m, or I just save it in with the same function I'm going to call. I'll show you that later. But anyway, you could save this as EQNS.m, and then you could solve it that way. You could set up a vector with two values in it, send it to EQNS, and it would return values of the two functions at those values of x and y. Then the return is going to return the two function evaluations, so we have to return a vector. I call that FCNS. And then FCNS1 is the first equation, FCNS2 is the second equation. Right? So that's how this works. If you have, say, 5 equations and 5 unknowns, z would have 5 elements in it, and there'd be 5 functions here. But it's a straightforward extension. So now we just call it. It's pretty straightforward. So as I said, x is our first variable in z, and y is the second. So when I make a guess here, I'm guessing that x is 2 and y is 3. So again, you just have to be consistent with this order. I send the guess to the fsolve routine along with the equations using this at operator, and it returns a result. That is, it returns a vector for x and y that will give, within some small error, zeros for those two values, or solutions to those equations. right? As an alternative, if you want more input, more feedback regarding how the solution went, you can put 4 outputs in your solution. You can have the result, the fval, which is the values of the functions at the answers, the exit flag, which tells whether it seemed to fail or not, and then various things in an output uh, structure that I'll show you in a moment. Okay, the call is the same either way. So you can either just have it return a result or return several items. Here's the function all put together. Okay, so I put this in a single function. I call this function solve EQs. I put my guess. I look at the output, and then I have it echo back each of these 4 outputs. And then the function in this case can be in the same file. Okay, and that's basically it. You run that through Matlab, and it'll give you the answer. When I did that, I got this. So notice here's the result here. X is 2.6963 and Y is 3.3655. The functions evaluated are of the order of 10 to the minus 12 or 10 to the minus 13 at those values. One thing I did is I put my guess back into the equations just to get a sense of how big the functions are at my guess, which is nowhere near the root. And they're of order 1, right? So I started with a guess which gave functions of order 1, and they ended up order 10 to the minus 13. So that's pretty good, right? The exit flag is 1. And down here, this output, it says it took 4 iterations. It evaluated the function 15 times and tells the algorithm, etc. So that's basically it. These things are pretty easy to use, and you should be able to do it with just about any system you want. Just be careful entering the data, and then be sure you have a good guess. Thanks.